Nicolas Salet. I'm a developer for Odoo. Uh, I will show you here how to load test Odoo, and I will present the tool we have built with Anthony to load test the server we have shown during the keynote. If you have seen the keynote, Anthony shown a server with 10,000 users running on an Odoo instance while he was using the Odoo backend. So here I will show you the tools I have used and how we have built the scripts to load test and how to achieve those load tests. So if you have any questions, there is a path to write your questions, or here is the QR code to scan to reach the page where you can ask the questions. The QR code will be shown from time to time during the presentation, so feel free to ask the questions. This talk will be done in five steps. A big introduction, shown on how we load test the backend, how we load test the front end, how we distribute the load test, and some kind of conclusion. The aim of a load test is to ensure that a given Odoo version with given customization, with a given infrastructure, handle a given workflow. It's not a good idea to test on a Raspberry Pi while you will run on a supercomputer in production. It's not ideal to test a vanilla Odoo without any customization on a supercomputer while your production will run with thousands of lines of code on a Raspberry Pi. So it's not realistic. If you are testing the sales module while your customer mainly do accounting in Odoo, it's not a good idea either. And reusing the scripts you do from customer to customer are not a good idea either, because customers have different workflows, and reusing your scripts from customer to customer, you will test again and again the same workflow and not the accurate test for the customer. Load testing should be done in the right order. So you have to make your system work. Once your system is working, you have to make it work right. And once it works and it's right, you have to make your system running fast. It doesn't make any sense to load test in the previous stage, in the early stage of the project, because you will load test potentially dead code. So it's not a good idea. The load testing results are complex to interpret. I will do my best to teach you how to create a load testing, how to read the results, but it needs common sense to read the results. You have to try yourself, and yeah, with experience comes confidence. So I will say it multiple times, but don't test any production database, okay? Don't even a copy of the production database. Once you will do it, despite I said you not to do so, I advise you to disable all the mail servers, all the external providers, all the payment providers, and so on. Because if you load test with production payment providers, sending emails and so on, you will run customers, real customers, with real emails about fake informations. You cannot test any SaaS offer. If you load test Odoo on the Odoo platform, you will be blacklisted. It's prohibited by the the fairly use don't remember that. You also have to get an expected performance from the customer. The aim is to be sure that your system will be able to handle a given workflow. If you try to achieve everything running in less than a millisecond, it will take ages to reach the goal, and it's probably not the goal of the customer. Maybe the goal of the customer is to ensure that under load, the system will respond for every web page in under 2 seconds. Under 2 seconds for a web page is something affordable. It's something realistic. You have to test realistic workflows. If you have a customer with a salesman doing sales during the day, and the picking are done in the warehouse during the night, they are not done together at the same time. It doesn't matter to test them at the same time on the system. You have to test what will really be done on the system. You also have to test on the same hardware as the production system, because you have to ensure that the infrastructure you give to the customer will be able to handle the load you want him to handle. As you cannot use a production database, not even a copy of the production database, you have to use a fake database to test. To build a fake database, you will use a tool called Populate. It has been revamped in 18, so it's a new tool in 18. This tool just multiply existing records. So you create in every model you want some records, and this Populate will copy over and over again the existing records. I will use the term backend and frontend, and depending on the developer you are talking to, those two terms means different things. So I will explain what I mean by backend and frontend. By backend, I mean any employee with an Odoo access. By frontend, I mean any visitor of the customer website. The difference between the two is that every customer has backend users, or you don't have any management software, but not every customer has an e-commerce or a website. So you have to always load test the backend, not always the front end. The problem with the backend is you have multiple profiles. On the front end side, you only have some profiles. You have a customer filling a form or a customer doing a purchase on your e-commerce. Not that much. But on the back end, you have accountants, you have salesmen, you have guys in the warehouse, and so on. For the back end, we have an API called XML-RPC. For the front end, you just have to issue a web request. You issue a web request, we are simulating a web browser. The first one, the back end, is easy to simulate with code. The front end is easy to simulate with a browser. But we will have to pick all of that and push that in one piece of code. I will use a tool during this call, this talk. The tool is called Locust. It will be used through the web interface. It can also be used through a command line. So you can script the usage of Locust, or you can go to the web interface to ensure that to launch the test and check the result and so on. The load can be distributed. If you are load testing an e-commerce, you want to ensure the response time. You have users from Asia, from Africa, from America, from Europe. You can have tests issued from all those locations. The good part of Locust is that it's written in Python, and because it's written in Python, we can write a small add-on to Locust, which is called Odoo Locust. It's available on PyPy, and this small module is just a wrapper between Locust and the Odoo XML RPC API. So for our project, we will create a requirements.txt with 4 requirements. The Odoo Locust, obviously, the HAR to Locust, Beautiful Soup 4, and LXML. And we'll get back to that later on. And this is what Locust looks like. So you have just a web interface, and once you have launched your test, you have beautiful graph. If you have reached the Anthony's talk, you have seen those graphs. You have the number of requests per second, the response time, and the number of users on the system. So let's talk about the backend. Let's load test the backend. A load test of the backend is composed of multiple stuff. You have various profiles. Each profiles perform multiple task sets. A task set is composed of some tasks. The task sets can be executed by various user profiles, and the user profiles share the task sets. So, to load test my backend, I will have to write task sets, profiles, and reuse the task sets in the profiles. To load test the backend, I have a special object in the Odoo Locust library, which is called Odoo Locust user. An Odoo Locust user is a backend user. Each Odoo Locust user is a simulated backend user. For the task set, you have Odoo task sets and Odoo generic task sets. I will explain the difference between the two, but mainly the first one is an easy part to issue tests on a given model, and the other one also perform already defined actions. Based on what we've seen earlier, an Odoo Locust user can have multiple Odoo task sets to simulate his daily job, and an Odoo task set is shared by different Odoo Locust users. Let's say you have a task set which is creating an invoice and validating it. Maybe the salesman doing them, and the accounting guys also do create invoice and validate them. So they share this task set of create invoice. Okay, let's try the first test. This is what it looks like. So we have a profile, a class which inherits from Odoo Locust user. This task have information like wait time. The wait time is the time between two tasks. When you have a user in your system, they don't frantically click in every button in the interface. A user reads what is on the screen, wait a bit, but it doesn't wait always the same amount of time. So wait time equals between a float and another is a random time to wait between two tasks. Then you have a task, which is here read partners. So you get the model REST partner, you search for no particular criteria with a limit of 80, and then you read the field name. It just simulates the list of partners. That's what it's doing. It's done through XML RPC. You have the login, the password to the database. The protocol, you have JSON RPC or JSON RPC S. The difference between the two is it secure or not? If you are on port HTTP, you are using JSON RPC. If you are using HTTPS, you are using JSON RPC S. And you define the port. So now let's write another test. It's still a backend user. But here, the user will perform two different kinds of tasks. The two task sets we have defined inherit now from Odoo generic task set. We just have to define the model name. If you create a class which inherits from Odoo generic task set, and you define the model name, what the Odoo locust will do is, okay, I have a model name. I will retrieve the list, the form, and the Kanban view, as well as the search view with the filters for this model. Based on that, I will randomly use the list view, the form view, or the Kanban view. And based on the filter, I will randomly search based on the filters I found in the filters view. So I will add random searches, and those random searches will be done with the filters. You will really test what people really do. People really use filters during their daily job. We have two different task sets, but the people don't do the actions the same amount of time. We have a salesman. The salesmen go more often to the leads rather than partners. So in the tasks definition, you have the name of the class. Here we have partner and lead. And after that, it's a dictionary. And this dictionary, the key is the class. And the value is the weight, the probability of these tasks. Here we have lead 5, partner 1. That means when the user will perform tasks, on average, he will run 1 partner task for 5 lead tasks. Okay? So here we are already testing the search, the views, the read of the field. If the fields are computed, they are really computed and so on the system just by some lines of code. I would like to simulate action other than just a list view, a Kanban view. So I can add tasks. A task as just a decorator. This decorator can also take a parameter, because when you go to perform a test on the lead, you probably go more often in Kanban view rather than list view, and probably more often in the form view rather than the Kanban view. You can add weights to the tasks. So if you don't have parameter, it's a default value of 1. If you give a value, the system will randomly choose based on the weights of every task. So here I still inherit from the Odoo task set based on the sale order, but I define different tasks, and those tasks are written in RPC calls. It looks like some Odoo code, but it just looks like each line of code is a call to the server. Each line of code is a transaction of the server. It's not exactly the same as you write a method in Odoo, because a method in Odoo is always executed in its own transaction. Here we have 4 lines of code, we have 4 transactions. We have created multiple task sets in a various way, but we want to create multiple profiles. I've said that the task sets are reused by the profiles. Here, I will create 2 profiles with 3 task sets. The first one will use all the task sets. The second one will only use 2 of them. The first one will only go to sales order from time to time, while the second profile will always go to the sales order. When you define a profile, you have a property on the user, which is weight. Again, the company is not composed of the same amount of people per department. You have more salesmen than accountant. You define the weight. The weight will give you the amount of people you have in each department. It's not always easy to write a test, so prior launching 10,000 of users performing the tasks we have defined, probably we want to test just one user at a time. To test just one user at a time, from Locust you can just import run single user. At the end of your Python file, you add this line. This will run only this profile again and again. He will run this profile, and once done, rerun the profile, and so on. That way, you will be able to test one user, your task set, debug your task sets, prior launching them by thousands. We have done the back end. Now, let's go to the front end. Here is what looks like a front-end test. It's exactly the same as the other one. So, Locust is a framework to test websites. So I don't need Odoo Locust to test the front end, because Locust is already built to test the front side, for the website. I just have to use the fast HTTP user class from Locust. I create a profile which inherits from this, and I will use the Locust built-in class to perform the test. The rest is exactly the same. You define a wait time. The host is a bit different because you just have to provide the full URL of the host. You don't have to provide the JSON RPC, JSON RPCS, the database, no login, no password, of course, because on the front end, people are not logged in, they are front-end users. As the test will be run again and again, we will have to perform two things at the beginning of the test. It's close the client pool. If you don't close the client pool, the system will reuse the existing connection. So you will not close the connection and reopen the connection. So you will not create the load that real user will create on your web server. That's the first one. And the other one is the cookie jar. You have to clear the cookie jar because the order ID is stored in cookies on Odoo. If you don't do this, you will simulate one user. It will add a product in his cart. This will create an order. You will confirm it. And when you will run the test in a second time, the system will reuse the exact same order ID. And as the order is already validated, you will face issues in your tests. So cleaning the client pool and the cookie jar makes each run of tasks running a new user on your websites. Once done, you just have to perform, it's using requests to perform web requests, so you just get /shop or whatever. As in the previous class, you can use the run single user, and you will test one user at a time, the test you just defined. In our requirements.txt file, there was this strange requirement, the HAR to Locust. It's really annoying to create a script to simulate a front-end user performing purchase on the website and so on. So the idea here is you use your web browser. You go in the network tab. You preserve the log. You perform all your tests. Once done, you download the result of the network tab. The result of the network tab is an HAR file. Then with HAR to Locust from the HAR file, you will get a full Locust test, which is the scenario you have created in your web browser. Here it's in Chrome, and in Firefox to download the HAR file. The location is a bit different to download the HAR file, but it's exactly the same. The idea is to load test the platform, not the load testing platform. Okay. If I use the HAR to locust to perform a test, the system will purchase again and again the same product. What I want is purchase different products. One way to do this is to use Beautiful Soup. I use /shop. I parse the result, and I randomly select one product in the page. This works perfectly. If you run this 10,000 times in parallel, the only thing you will do is burn CPU on a load testing platform and not at all on the server, because it takes too much time to do this. So the idea is to generate the product IDs in the text files and reuse them instead of parsing the result here. Of course, they are part of the result you should use. They are part of the result you must parse. For example, the CSRF token must be retrieved from the pages, because there is no other choice. In the dependencies of Odoo locust, there is also a dependency which is names. Names is a Python package which generates real names. You have get first name, get last name, get full name, and multiple other methods which return names. It's very important to use them because in Odoo we perform searches with contains blah blah blah, and this works well when you create trigram index on the fields. The trigram index all trigrams in a string and points to the records containing this trigram. If you always use the same name, or always use random user 1, 2, 3, 4, you will bloat the trigram index. So the trigram index will not work at all if you don't use real names. The other point is, I've said that in the backend, I'm randomly searching for stuff in the views. I'm also using names in this library, and then I'm really sending real names in the search. That means when I search for, let's say, David, I will retrieve all Davids from the database, because there are David in the database. And I have a real way of work from the system compared to real life. So I advise you to really use some library. I'm using names, you can use whatever you want. If you explain to a customer you have found a library, he will explain that he has a better one for whatever reason, but I'm using this one, you use whatever you want. Another way of performing the load test of the front end is to use the realistic URLs from the logs. You download the Nginx logs from the customer, and this Nginx logs is full of requests. You search for the get request in the Nginx logs, and you have the load test of your website. We've done the front end, we've done the back end, and now we have to perform the load test. So first of all, for now, everything is tested with the same user, which is the admin. It's not good because we have record rules, and record rules are generally speaking an issue in performance. In Locust, every simulated user is a thread. Each time Locust needs to simulate a user, it will launch a thread to simulate this user. If you have already heard about the jail, you know that all threads run on one CPU. So it's also an issue. And the third issue is, if you load test with your laptop, you will load test the network card of your laptop. You will not load test your system, you will load test your network connection or your router or whatever, but not the system. So you have to load test with a server near your production server. You need enough resources to load test. So because the usual source of issues is the record rules, here I've created a users.txt file which contains login and passwords. With those logins and passwords, I will be able to load test the system using those real users. If the 2FA is activated on the database of the system, you cannot simulate the 2FA. You cannot type TOTP password 10,000 times a second. It's not possible. So the way to circumvent this is to use API keys. We are using JSON RPC and JSON RPCS. We are using the API. You can create API keys instead of passwords for the users. And you just have to reuse them in your scripts. Every piece of code I'm showing here is available on GitHub. I will give the link to the GitHub repository at the end. So in the repository, there is the file to create the users, to create the products, the load test, everything is in the public repository. I've said earlier that we can test multiple user profiles, but we have written a file with a front-end user and a file with a back-end user. You can even have multiple back-end user, multiple files with front-end user or whatever. The simple fact to import a profile in another file of profile will make Locust able to use them during the load test. Here, in the backend salesman, I'm importing the web shop. If I run the load test of the backend salesman, he will also run the profile of the web shop. So you can either define all your profile in one file, or you import the profiles in your test file. Don't forget the weights. I've said that we are facing an issue with the jail, so I need to launch multiple Locust workers. In Odoo, we have workers. In Locust, we have workers. That's two different stuff. It's the same word, but two different stuff. So here, I have a small script which will launch a given amount of workers. Those workers are waiting for the master worker to give them work and will perform the job the master worker will ask them to do. And finally, we launch the test. There is a headless parameter in the Locust file you can use. If you run the test with the headless, the system will perform the test, and once the test is done, will stop and output all the results in a CSV file you can parse afterwards. So with the headless, you have the results in a CSV file. If you don't run in headless mode, you will get the result in a web interface. Okay, let's do a test. Here I have two graphs. The first one is the number of requests. The second one is the average response time of the system during the test. The only difference between the two is the number of users. On the second test, we reached the limit. When you have graph like that, you know that you have reached the system limit. You can't go further than a given amount of users. But how to detect the number of users? I will just automate a test, and I will run more and more users. I will run Locust in headless mode, and I will just run a given amount of users, then 10 more users, 20, 30, and so on. When you launch a test with a given amount of of users, Locust doesn't launch all users at the same time. There is a parameter called spawn rate. This parameter explains to Locust how many users it should launch per second. When you run a huge amount of users, you have to run the test at least the time for Locust to launch all those users. Here is my ramp-up loop test. Here is my result. So I have the number of requests for the first graph. The second graph is the concurrent requests, the average response time, and the CPU usage. In fact, here we can see that the system is already fully loaded on the first test. The first test is already fully loading the system. The only difference between those tests is the response time, in fact. The system is running at 100%. Each CPU is running at 100%, but the response time is increasing. The system can only handle a given amount of number per request. That's the reason why you should ask your customer, was this an acceptable response time? Because all those tests were successful. The only difference is the response time. What is the acceptable response time? Let's perform a test. Here you have the Locust web interface. The first graph is the number of requests per second Locust is launching. The second graph is the response time. You have the percentile 50 and percentile 95 of the response time. And the third graph in blue is the number of users you are simulating. So the first test is, I think, 7,500 users, and the other one is 8,000 users. In both situations, the system is correctly handling the load, and the response, the percentile 95 of the response time is mainly the same for both tests. So let's add some more users. Let's add some more users, and here is the result. You have a big difference in the percentile 95 of the result. The percentile 95 of the response time is not at all the same as the previous one, but the number of requests per second is exactly the same. The system can only handle a given amount of requests per second. And if you add even more users, then you explode the system. Now the response time is not acceptable at all. If you compare the first graph with the fourth one, you noted that the fourth one is double the first one. When you reach, when your percentile 95 is twice the previous one, you have reached the system limit. Let's test another thing. Here is the test with 10,000 users on the system Anthony uses for his keynotes. We are only simulating front-end users here. What we are seeing here is you have an explosion of the percentile 95 of the time, and then suddenly everything goes correctly. But no users were deleted or whatever. In fact, you have to know your tests. Here, the system is performing users performing a purchase on your website. So they call the /shop page first. as they call the slash shop page first, and as this page was a bit heavy to generate, the response time for this page is higher than other calls, so the percentile 95 increase. But when all users are launched, there are random time between clicks. So the time is don't remember how to say it. So you don't have calls for slash. You don't have too many calls for slash shops at the same time, but you have a huge amount of other calls which are really smaller than the others. So the percentile 95 decrease because the calls are split between the different kinds of calls. So reading a graph means also knowing what's happening behind the scene. The same test, but here we have 18,000 users, and clearly 18,000 users is too much for the system. For these given systems, you see the percentile 95 just increased because the system can only handle a given amount of requests per second. The requests are queued, and at some point they are dropped and whatever. So we are way too much away from the point where the system is performing correctly. And finally, you also have to detect what's happening behind the scene. You have a test here. Clearly the system is overloaded. You see, you have a look at the CPU usage on the system, and you see that the CPU usage is low. The response time is very high. What's happening? There were a table which was bloated on the database. It was impossible to insert a sale order. The website is down. But it's not a matter of CPU or whatever. It's a matter of configuration of the database. So just reading the graph is not enough. You have to look at the graph in locus, the graph of your system, knowing your test, and so on. Some kind of conclusion. So you have to test the front end and the back end. You should use real use case scenarios. No production databases, of course. And you should put realistic expectations. Here is the link to the code. All the code I'm using here and all the code Anthony was using is available over there. So feel free to download, test your system, load test your system. Thank you.
Thank you, Nicolas, for
You're
your
welcome.
talk. Do not hesitate to ask some more, to add some more questions on the pad. We'll answer them. We have plenty of time. First question is: did you manage to literally burn a server?
Yeah. Yeah, if you're friendly of the planet, I was not your friend last week.
Okay. So there was a +1, so everybody wants to know.
Yeah.
But now everybody knows. Can we test on a neutralized copy database?
Yeah, the neutralized copy database, it means you don't have any mail server, any payment provider or whatever. Yeah, you can test it. But neutralized database means real production data on a test system. You will create test users. It's not ideal. It's easier, but it's not ideal. But I know that people do that, so.
Okay, so no problem.
See, it's a problem, but.
Okay. What is for you the best way to monitor the usage of a database in order to create realistic performance testing?
The best way to monitor the usage of a database in order
To create
realistic performance testing. The best way to monitor the database is use in the PostgreSQL configuration. You can add a parameter which is the minimum execution time after which the query will be logged. You set it to 0. You will log all the SQL queries. Given on the SQL queries, you know what you have to load test. It's the first way of doing it. The other way is to look at the Odoo logs. In the Odoo logs, you have the calls. There are all the calls to the system. You analyze the calls to the system. Based on the calls, you deduct what people are doing. Based on what people are doing, you create your tests. And that's the best way to achieve this for the back end. For the front end, you just have to go to the Nginx logs, get the Nginx logs, and create tests from that.
Okay, thank you. Is there one or several specific modules that we need to define these tests in?
No, no. It's just a Python file. It's not an Odoo module. It's just a Python file on your computer.
How does the populate tool work?
The populate tool work in SQL. You create data in your database, and then this tool read the data and insert what he reads. He performs some kind of magic on the dates and so on to not have all records at the same date, or if you don't do some magic on the dates, the accounting is crappy and so on. So we have to randomize a bit the dates and stuff like that. But it's mainly copying again and again the existing data from the database. So you create two partners, Alice and Bob. You ask him to multiply by 10,000. You will have 10,000 Alice and 10,000 Bobs, and that's how it works.
Okay, thank you. How to test with a portal user?
Oh, the portal user is just the web testing, but you have to ask to call the form to log in the user. This will log the user in the session, and each call afterwards will be done with this session. The session is reused all test long. As soon as you call the function which discard the cookies, and then the session. So as soon as you get the session, you are using the same user, so you just have to call the login of the user.
Okay. What is the process to test a base on Odoo SH?
You can't.
Okay, that was a simple answer.
You can test. It's not possible to test on Odoo SH. It's not possible to test on Odoo.com. It's not possible to test on any SaaS from any partner. Or you have to ask the provider prior this testing. With this kind of test, you will trigger thousands of queries. You will be blacklisted in seconds. So it will just don't work.
Okay, thank you. Does testing with JSON RPC with your helper classes do what the client would do, like load the views, read the fields of the views, etc.? Does it send a request to get the images in Kanban view?
The images in Kanban view are not triggered because it's just a call to get a static file, so it doesn't create. It uses bandwidth, but it doesn't use loads on the system. The system is calling get views. The get views will get the list of fields, etc. You go to the Odoo Locus package. The Odoo Locus package is open source, and you have access to the tests. If you want to improve the Odoo Locus package, feel free to send a pull request. I will be very glad to approve your pull request.
Okay. Can I use Locust to test FastAPI that performs action on Odoo?
I don't know.
Okay. We don't know. Let's say a table is accessed written on a lot, like stock moves lines, for example, which causes a lot of concurrent accesses. Is there any way to configure Postgres on Odoo to avoid that?
If you have lots of concurrent access on a table, don't know how you can avoid the concurrent access. There is a mechanism in Odoo with the concurrent access. When you have a concurrent access, Uh, your system is your transaction is rollback because, and you see in the logs the serialization failure, and there is a retry mechanism in Odoo. The Odoo will retry up to 5 times your requests, and he waits a random time between retries. So if you have 2 requests which perform the same call at the same time, the first one will be committed, the second one will be rolled back because of an error, but it will be retried. And this second retry will probably succeed or also fail because another one failed and so on. So there is already a mechanism in Odoo to retry that.
Okay, so here again about Odoo SH. So for the Odoo SH, we must download the base, but are there any tools or other to simulate Odoo SH?
Odoo SH is just an Odoo. If you have to load test Odoo SH, either you have to ask the Odoo SH team, but they probably will answer no, because the only way to load test Odoo SH is to load test your production database, because the other databases on Odoo SH only have one worker, so it's not the same as the production one. So you have to create a copy of your project. You will have to ask them if you can do this. But if you load test on your local machine the Odoo SH database, you will load test mainly your custom code, and based on your custom code, you will retrieve the issues in your custom code, improve your custom code, but there is no way to load test Odoo SH. No safe way at all, at least.
Could you provide some information about this new database router and performance improvements?
New database router and performance improvement. What is a database router?
I think you'll be able to come discuss that at the end of the talk.
Feel free to ask.
And here, like read/write cluster.
Oh, it's just you can flag some routes call as read-only, and the system should be able to route the query to another PostgreSQL connection pool. That's mainly the idea. It's not on production on odoo.com for now, so I can't tell that much how it performs, how it works. It's as soon as it's not in production, I cannot really answer and give accurate information about that.
Okay, thank you. And the last one is not a question. It's a thought that we all share. Cool and useful tech. Thank you very much, Nicolas.
Thank
you all for listening.